Okay, so then I'm going to talk about how to create network segmentation using VLANs. Now, previously I did a video that talked about how to do that using something like commercial-oriented routers, where you can take a couple of those and chain them together, and that allows you to have multiple zones, and those zones would be for things like IoT devices, and they're isolated from, say, your laptop or your phone, and that's for security reasons. Now, you can do the same thing with VLANs, but it's a much more sustainable and scalable approach using some standard protocols and some commercial gear. Now, you can get your hands on some of this gear by simply purchasing some gear that supports it, and you don't have to spend a lot of money to get your hands on it. It just requires a little bit more knowledge and configuration than, say, using a couple of consumer grade routers. But it can actually work better and also be cheaper in the long run, depending on what your needs are. So I'm going to talk about what a VLAN is and kind of how it works. And then I'm going to go through some of the gear that I have that I didn't spend a ton of money on, but was able to set up a network in my home and office using this gear, and was able to get that nice isolation that I previously had, but without spending a fortune on the network gear. So let's talk about a device that people are going to be familiar with, and that is a residential router. Now, a residential router is a single device that controls your entire network. You plug it into your ISP, and then you can configure a wireless network, and it might have some ports in the back where you can plug some Ethernet into, and that single device does everything you need for your home or your small office. Now, if you're a commercial setup, you're going to need something much more sophisticated than that to scale a network beyond a single building. That's the typical size of a residence. Maybe you're talking about a hospital or a school. And so it takes the functionality of something like a small single device and branches out into really three different kinds of devices, maybe four, depending on how you look at it. And those different devices are what we could think of as a firewall router, which are typically combined into a single device, although they can be separate in the most technical sense. And then you have a switch, and that's represented by the Ethernet ports. And then you have an access point. Now, the reason why you break this out in a commercial setting is because typically you're going to be covering a lot of square footage with networking in a commercial setting. You might only have one or two actual firewalls or routers to connect to the internet, but if you're thinking about connecting something like a large hospital or a factory or a school, you're typically going to have a lot more area to cover with a network than you could do with a single device. So to accomplish that, you're going to actually need probably multiple switches for all the Ethernet that you have to run, and then also multiple access points to cover that entire building or area with Wi-Fi. That's more than a single device can do. And it's also going to have a lot more traffic on that network than you would typically have in a residence as well. So you're going to need something that can handle that additional load, which would quickly overwhelm a residential access point or router. And so the combination of these multiple devices provides you with the ability to create larger networks rather than having a single device to manage a whole network. And so with that in mind, if you want to get network segmentation, you need to figure out a way to provide that network segmentation. And that's where VLANs come in. And VLANs are just basically the ability to create virtual LANs on top of the physical hardware, but you need to do it in a way that is standardized so that all of these devices that you have represented here, your access points, your switches, and your firewall/router can communicate. And there is a standard protocol for that. And that's where I want to kind of unpack and talk about how that actually works. So now that we've kind of understood the basic gear that we need to make a network work in a more commercial setup, let's add some clients to this. I have two laptops, a desktop, and maybe another laptop down here. And the way these connect together is on the same physical network. So I have an ISP coming into a firewall router, and then from my firewall router, I come down into a switch. And the switch has its own ports on it. And sometimes firewalls have a built-in switch, but for this purpose, I'm treating them as separate devices. And then I'm going to wire up this desktop PC by way of a wire down here. Then we'll put a wire into this access point, and then I'm going to allow these laptops to connect by way of Wi-Fi to the access point. And so this is the physical network, a fairly straightforward physical network. And if I just wanted a single network, that's all I need. I'm done. In fact, I wouldn't need a lot of fancy gear to do this either. But I'm going to carve this up into separate networks. I'm going to isolate a couple of these machines from one another using VLANs so that they share the physical network, but the VLANs provide isolation. So for our scenario here, I'm going to basically use these two devices down here as one network. These are, say, my guest network, and I'm going to use these devices over here as my so-called main network. So I'm going to put a pretty good divide between these two different networks with different VLANs. Now, the way this works is with a concept called VLAN tagging. Now, VLAN tagging typically happens on the core gear, but let's not get too far ahead of ourselves. Let's just talk about kind of how it works at first. So the way that this works is whenever you have a machine connect to a network that supports VLANs, the network is configured to recognize that particular machine, where it's coming from. And it's basically going to designate its source as part of whatever network segment that you're coming from. So in the case of this desktop PC down here, I configure the port right here on my my switch to say, hey, all the traffic coming off of this port that is untagged traffic, that means it doesn't have a VLAN tag on it, is going to be tagged by the switch with a VLAN ID. So I'm just going to assume that I'm going to be using 10 for that particular VLAN. And so all the traffic that comes off of this box down here, it just sends it just like it would if it was just connected to any old regular network without VLANs. And then it gets to the core switch right here, and the core switch says, oh, that's not tagged at all. I'm just going to assign it a tag because I said all the traffic on this particular port is for VLAN 10 segment. And in a similar way, down here on a Wi-Fi connection, if I wanted to send traffic over here from this device, it's going to connect to this access point. But this access point sees that it's connected to my main network. And so instead of the switch actually doing it, this access point right here is going to tag all the traffic that this device is sending with VLAN ID 10. And then it sends it up this wire to the switch. The switch then sees that it has been tagged with a VLAN ID of 10. And so it doesn't need to change that tag. And then this basically creates that VLAN on this different devices between this desktop down here and this laptop using this VLAN ID of 10. So this allows this machine right down, this desktop machine, to talk to this laptop without any kind of hindrance between the two because they're on the same VLAN ID. Now, let's talk about these two machines over here. And so these are going to connect to the access point in the same way that this first laptop did. So this laptop right here sends untagged traffic to the access point. It sees it's untagged traffic, but it's coming from a guest network. So it says, oh, that's a guest network. So that's going to be VLAN ID, say 20. Okay. And the same thing down here. This one is going to connect and it's going to get all its traffic with the VLAN ID 20. And that's going to flow up the same wire that all the traffic from this guy down here is sending up from VLAN ID 10. But what happens in this case is the switch right here will not allow the traffic from this laptop to talk to the PC over here on the right, or this laptop over here to talk to this PC on the right, because the traffic source is coming from VLAN ID 20. It's going to isolate that based on the VLAN tag. And so it will not allow the traffic from these two devices down here on the guest network to work with this machine, but it will allow the traffic from this device down here on the main network to communicate with this desktop PC over here. But all of that traffic can flow out to the internet. So from the switch, it's going to go up the wire to the firewall router, and then the firewall can then send it out to the internet. Now, in the case that I actually do want to allow VLAN 10 and VLAN 20 to talk to one another, I can do that, but it's going to end up going back through the firewall. So say I wanted to access something over here on this desktop PC from this device over here. And to do that, what I'm going to do is I'm going to connect just like I did before. And instead of the traffic flowing freely over this wire right here down to this guy, it's going to go up into the firewall. Now, the firewall has the ability to route traffic between networks. That's kind of what a router does, is it connects two or more networks together. In this case, it's connecting actually three networks together. It's connecting two VLANs and the internet. And so it can route traffic from the VLANs to the internet, which is what you would expect, but it can also route traffic from the VLAN to VLAN. But if it does that, if I take traffic from VLAN 20, send it up here to the firewall, what it's going to do is it's going to route the traffic just like it would if it was internet traffic, but it's going to send it back down onto the network. But instead, it's going to send it with VLAN ID 10. And then it's going to be able to filter and scrub that data just like it was traffic off of the internet, but it's coming from a different network segment. So yes, just because it's isolated using VLAN tagging doesn't mean the networks can't talk to one another. They just get routed just like they were separate physical networks on your firewall router device, whatever that might be. So in the most basic sense, this is kind of how VLANs work. It's a standard, and so you don't have to worry about any one device implementing this in a different way. So a Palo Alto firewall will work with a TP-Link switch, which will work with a Netgear access point, which I have here. In fact, I use Hyper-V, pfSense. I use TP-Link switch and a Netgear switch, Netgear access point on my network. And they all support the standard. So as long as the device implements the standard, then you can get VLANs working on your network. So let's talk gear for a minute. Now, I built my network with budget in mind. So again, this is going for something that's very budget conscious. And so I bought the gear that would support the use cases that I needed without spending a ton of money on networking gear. So your mileage may vary, but this is the gear that I went with. So for a firewall, I went with open source software, and that is free. And I'll explain the asterisk here in a second. But pfSense is an open source firewall software that you can download, and it's free to use for anybody that downloads it. But you need hardware to install it on. So the software itself is free, but the hardware you'll have to acquire. And it might be free to you if you have an old PC laying around or an old laptop laying around. And what you can do in this case is download pfSense and put it onto a USB drive and install it onto that old PC. It could be a desktop or a laptop. Now, I use the laptop option. And so to make that work, you need to upgrade either the desktop or the laptop with a second Ethernet port. And that's actually really easy to do. With a desktop, you can do that with a expansion card and add another Ethernet port that way. And then, or you can use USB and use USB to Ethernet. Or like I did in my case, I use an old laptop. It has a built-in Ethernet port. And then I just use USB 3 to Ethernet, and then I added a second Ethernet port. And then for my configuration, I put the USB on the wide area network side, the internet facing side, and then I put the local area network on the built-in Ethernet port, and that gives me a firewall. And it also happens to have a built-in screen, keyboard, and battery for even more robustness and backup in case the power goes out and all that fun stuff. But in any case, that's just some added features of using an old laptop. But in any case, I wouldn't necessarily use that in a commercial setup or business context, but for home, it's great. And I've been doing that for probably 15 years in that particular configuration. But the next configuration thing on my list here is a switch. Now, I wanted a managed switch to get VLAN support, and that is one of the most basic features of a managed switch. Now, a managed switch versus an unmanaged switch is basically the ability to configure the ports on the switch. Unmanaged switches do not allow you to configure the ports, while a managed switch allows you to do that. And one of the ways that you do that is with VLANs. And so I went with a gigabit managed switch, and I wanted at least 8 ports. And the option that I found that supported that was this TP-Link SG108E, and it's for $30 on Amazon. For $30, this is actually a really nice switch. It's got a metal chassis and shielded ports, and it gives you a lot of features that you can use, especially VLANs, to configure all of these different ports that are available on it. Now, they have a 5-port version and an 8-port and so on that you can purchase, but for $30, an 8-port switch was perfect for my needs. In fact, I have I think 1 or 2 extra ports on this thing that I'm currently not using. But this particular one is more than enough for everything that I'm doing. And I actually have some unmanaged switches hanging off of this. Like I have some unmanaged switches for like my cameras. I have a PoE switch, which is an unmanaged switch for a couple of IP cameras that I have for security purposes. And I just basically have that as a separate VLAN ID for my IoT network. And that comes in on a specific port on my switch, and then that goes back up to my pfSense firewall. And then my pfSense firewall allows me to manage all that traffic as if it was on an isolated network. So I'm able to isolate my IoT devices doing in that scheme. Now, of course, I've got some IoT devices on Wi-Fi as well, and I isolate those to the same network using VLAN IDs, of course. Now my access point comes in on a particular port as well, and it supports multiple VLAN IDs on a single port, depending on what you're doing. But all that to say is you need a managed switch, and you can get one of these on Amazon for as little as $30, maybe less, depending on what your needs are, because there is a 5-port version of this, I think, for probably about $18 or something like that. So with that in mind, I needed an access point for Wi-Fi, and I went with Netgear business class stuff. And I went with this particular one right here, the WAX214V2. And this particular guy is a Wi-Fi 6 device that supports the AX1800 standard. And that 1800 standard basically means that I can have up to 1.8 gigabits of bandwidth on Wi-Fi coming into this guy, but this thing only has a gigabit port. So the actual Wi-Fi is faster than what this thing can do on Ethernet. And so given that this thing only has a gigabit port, that means that I'm probably never going to be able to take full advantage of the maximal potential Wi-Fi connection speeds that I could get out of an AX1800. In reality, I typically don't get anywhere near that. Even with a device that supports Wi-Fi 6, I'm typically only getting somewhere around probably 1.2 gigabits per second optimally. And more realistically, on most of my devices, which are typically Wi-Fi 5 or Wi-Fi 4, if it's an older machine, I'm getting more like 500 or 800 megabits per second, which is still, again, more than I need for the kind of use case that this is typically serving, which is a streaming, that I might have multiple devices streaming content at the same time. And that does not require a lot of bandwidth such that I would need something like a 2.5 gigabit connection back to my switch in my firewall. In fact, 1 gigabit is actually more than enough to handle that use case, and which is why I didn't buy a more expensive access point. So for the combined total of a $30 switch and then an $80 Ether access point, you can get out of the door for about $110 for a more commercial grade network. Now, of course, you can buy gear that supports VLANs that is consumer oriented. It's typically going to be a higher end access point router device that does support VLANs, and certainly that's a valuable option. I wanted to kind of separate those two out because this device right here lives in a different room, and it kind of comes, it's closer to the firewall and also to where the managed switches are, unmanaged switches are in my house rather. And this device right here is not. This is in the middle of my house, and I basically ran some Ethernet through the attic to install this guy in my house. I originally had planned on putting 2 of these in here, but after I put the first one in and I tested it, it covered my entire house plus most of my property without the need for a second access point. I had originally bought 2, but I only needed 1, so I ended up selling the second one to a friend of mine, and he put it in his house and has been using it ever since too. And it's a great option. And I also went with PoE with this guy as well. So for the combined total of like $110 here, you end up with what you need. Now, there's of course some sundry costs that you might have associated with your network needs, depending on what you're doing. In my case, I needed to buy some cable to do an Ethernet run. I put in, I think, Wi-Fi. I put my access point on Ethernet Cat 6, I think. I can't remember what I used. Cat 6 or Cat 7, one of those two. I can't remember. But it was something that was future-proof, essentially. It's something that I could run, and then I could upgrade it in the future if I so chose. And it wasn't a a whole lot more expensive than just Cat 5e or something that was a more inexpensive option. So I went with that. And I also needed a PoE injector for this guy. I used a separate PoE injector on my access point rather than using the PoE switch because I wanted to isolate it from that IoT network and also bring it back into this switch right here. And plus, the power demands of this device are significantly higher than the cameras, and I don't think my Ethernet PoE switch would have handled this device and both cameras at the same time. So I used a separate PoE injector and then cable to augment this guy and to give me a full network setup that I'm currently using, in addition to what I kind of already had, which was existing Ethernet cables and existing devices and so on to upgrade my previous network. And then there's some other gear that you might want to consider for this. If you're doing something like power line Ethernet, you might want to do that. Or if you're doing something like Ethernet over coax and using that as a way to get Ethernet around or network around your home, there's certainly other things that you might want to consider as part of this setup. But for a network in my home, this was more than enough for my needs, and it was a fairly budget-friendly option to get me the kind of isolation that I wanted, but also doing it in a way that was more a commercial setup, if you will, that gave me the VLAN isolation between my guest network and my IoT network, my main network, and so on that I currently have on my network at my house, but also gives me great options for extensibility and also a very sophisticated firewall in the context of pfSense.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.